In the last video, we looked at uncorrelated subqueries, which are run once and are run independently of the main query. By contrast, a correlated subquery is not just run once. It's run once for each potential row of output in the main or outer query. So while an uncorrelated subquery is independent of the main query, a correlated subquery is very much dependent on it. The best way to understand a correlated subquery is again through demonstration. So let's write a query where we want to return for each customer the date of their most recent rental. So we're going to start things off by looking at the customer table. And for each customer, we want to return their customer ID, their first name, their last name, and I'll put a comma up here. We want to return one additional column which contains the date of their most recent rental. We can accomplish this with a subquery, but it's going to be quite unlike previous subqueries that we've written. Because if we were to just write a regular uncorrelated subquery here, all we would achieve is a query that will run once and just return a single value. What we want here though is a column that contains the most recent rental date for each customer. The value should depend on the customer. A correlated subquery will allow us to do this. So we can select from the rental table, and we'll alias that as R, and we want to add a condition where the customer IDs must match. And we want to select the most recent or the max rental date. And we'll alias that as the most recent rental. Let's run this query and then I'll explain it a little bit more. So for each customer, we've obtained a column that contains the most recent rental date, and that's different for each customer, so that's what we expect. Let me wind back now and just explain how this query has worked. For each row in this outer query, so basically for every row in the customer table, this inner query has been run and has returned a different result in each case. And what changed it from just being a regular uncorrelated subquery to being a correlated subquery is the fact that we referenced the outer or main query inside this query, and we did so because we referenced the customer table here. That is what changed this from being a regular uncorrelated subquery that runs once to a correlated subquery that is run for every row in the outer query. It sometimes helps to substitute in values when you're thinking about how this works. So you can imagine first looking at customer 1 from this customer table, and then this inner correlated subquery was run, and what it's done is gone select the max rental date from the rental table where the customer ID is 1. So substitute in 1 there, and that's returned the most recent rental date, and that's this date here that we see in the results. Now imagine that we step on to the next row, which is customer with ID 2. And so again, this inner query was run for customer ID 2, and it returns the most recent rental date from the rental table where the customer ID is 2. And that's this date down here in the results. So for each row in the outer query, the inner query is run. Unlike with uncorrelated subqueries, that means of course that you can't just run this inner subquery on your own. If you tried to select this and run it, you get an error. And that's because that reference to the table C doesn't actually make any sense if you were to just run it on its own. This subquery only makes sense in the context of the outer query, where C is defined. Let's do another example, and let's write a query where we want to return all the customers who have spent less than $100 with us. So we're going to be working with the customer table again. We'll be returning the customer ID, the first name and the last name from the customer table, and we want to say where, and we want to now write a subquery that returns us the total amount that that customer has spent with us. And we'll say where that amount is less than $100. So all we have to do now is fill in that correlated subquery here. Let's go ahead and do that now. So we'll select from the payment table, and we'll alias that as P, and we'll say where the customer ID is equal to the current customer, and we'll just sum up the amount. So what will happen when we run this is for each customer, we'll calculate the total amount of money that that customer has spent with us, and then we'll use this overall where condition to filter those customers who've spent less than $100 with us. Let's run that now. We got 204 results, so there's 204 customers who spent less than $100 with us. Let's verify some of those results to make sure it's correct. If we want to verify it, what we can do is just pull out this correlated subquery. Let's pop it down here on its own row. We can clean up some of the formatting. And what we'll do is we'll just substitute in some of those IDs that appeared in our results, and we'll make sure that they're correct. So we're told that customer with ID 4 spent less than $100 with us. Let's check that. Yep, they spent roughly $82 with us. Let's go back to our results. We can see that customer with ID 5 is missing. So let's check. And the customer with ID 5 spent $145 with us roughly. So again, that looks like that's worked correctly. In the last video, I mentioned that the exists keyword is one of the subquery expressions that's very commonly used with correlated subqueries. And I'll show you why that is. Let's imagine that we wanted to change this query, this main query that we have here, to just return us those customers that haven't paid us any money at all. If we just wanted to first change it so that we return customers who have made some payments to us, what we can do is just put exists here. And what we'll do is just select any rows of payment where the customer ID matches. We can clean this up, and I'll just clean up the formatting here a little bit as well. Okay, that looks better. So what this query is now saying, return all the rows from the customer table where there exists some rows in the payment table from that same customer. I can run that, and I actually get 599 rows, which is the number of rows in the customer table, which tells me that basically every customer has made at least some payment to us. So when you use exists, all that basically does is it performs a check to see if any rows are returned in the subquery. If any rows at all get returned, this exists check evaluates to true. If there are no rows in that subquery, then the exists check returns false. So right now this query is just returning us all those customers that have made any payments to us. If we wanted to return what we originally were trying to look at, which is those customers who haven't made any payments to us at all, we could simply say not exists. And there are none. When you're using exists, it actually doesn't matter what you return in the columns. All that exists is checking for is the existence of some rows. If there are some rows that get returned, then exists evaluates to true. And so this is why I used select star here, because it doesn't actually matter what columns I select. One common convention that you'll see people using sometimes is just saying select one. It doesn't make any change to the output, so you get exactly the same result if you use select star or select one. Personally, my preference is always to use select star. When you're looking at this query and thinking about what we were trying to achieve, again, you may find yourself thinking, I could have done this actually with joins. And again, as it is with uncorrelated subqueries, that's very true. It's often the case that you can choose to implement something using either subqueries or joins, and your choice should just come down to which way of writing it do you think is more clear and which is better from a performance perspective. I'll leave you now with one last really quite advanced use case for correlated subqueries, and that's for obtaining previous or next values. Let's clear away this query, and let's now write a query that will return us, for each rental, the date of the previous rental for the same customer. So we'll start by looking at the rental table. And I'm going to alias that as R1 here, because I know that coming up, I'm going to be referencing the rental table again in this query, and I want to use a different alias in each case. And for each rental, I want to select the rental ID, the customer ID, the rental date, and I want to select one more column now, which is, for each rental, the date of the previous rental from the same customer. So I'll write a correlated subquery here. And in this subquery, I'm going to be doing selecting from the rental table again. And I want the customer to be the same one. And I want to find the previous rental versus the one that's currently being referenced in the outer query. And the rental date has to be less than the current rental date. And I want to find the previous rental, so it has to be less than the current rental date, but I want it to be the max such rental. And I'll alias this entire expression as the previous rental date. So for each rental, what I'm returning in this correlated subquery is the last rental from the same customer. And so I've matched on the customer, and the way I obtained the last rental was by looking for a rental that's less than the current one, but has the max rental date. I'm looking for the rental that has the greatest rental date less than the current date. Think about that a little bit more if it's not clear how that's worked. And what I'll do now is I'll order by the customer ID and then by the rental date. Okay, this is a pretty complex query. Let's run this and have a look. So remember, I'm ordering first by the customer ID and then by the rental date. And for each rental, I've added a column where I return the date of the previous rental from that same customer. So we can see that for the first ever rental, for example, from customer 1, there is no previous rental date because there is no previous rental. So that's correct. For the second rental, which they made on the 28th of May, the previous rental was on the 25th of May. And those dates match, so that's correct. And so it goes for each rental from that same customer. I've obtained the date of their previous rental. And we can scroll down and have a look if that's correct as well for customer 2. So starting with customer 2, the date of their previous rental for their first rental is null, and each subsequent rental correctly refers to the date of the previous rental. Those match. So our query has worked. It's done what we wanted. That's a pretty advanced query, but it's actually really useful and cool. And in an end of chapter exercise, I'll ask you to extend this example and work out the average amount of time between rentals for each customer. That's pretty interesting information to know. As I mentioned, this is a pretty advanced query, and having introduced it to you now, what I will say though is that dealing with next and previous questions like this, subqueries aren't necessarily the most optimal approach, and in a coming chapter, we'll be looking at using window functions to achieve the same effect in a way that's a little bit better for performance.